right, today we are solving equations. So this is our second day looking at doing this, but today you can see the equations are much more complicated than they were the day before. So we have some steps that we need to follow. First thing is parentheses. If you see parentheses, we're going to get rid of them before we do anything else by distributing whatever is smushed with the parentheses, and we're going to multiply it with everything in the parentheses. Okay, so we'll talk about what we do next, but let's look at number one. So first thing I notice is I see parentheses. So I'm going to distribute whatever's smushed against them. Now, a lot of times kids will think the 8 is smushed against the parentheses, but it's not. Let's look. It's that negative that's smushed against the parentheses. So this is understood to be a -1. So I need to take -1 times the 2x and -1 times the -9. So when you distribute, you're multiplying the number that's smushed with the parentheses with everything inside. So -1 times 2x is -2x, and -1 times -9 makes a +9. Make sure you're always paying attention to signs. So it was a negative times a positive, which made a negative, and a negative times a negative, which made a positive. I'm going to bring down the equals and the 38. And then on the left-hand side, I'm going to bring down the 5x plus 8 because it has nothing going on with it right now. So I just bring it down. Okay, so that's going to be the first thing we look for when we solve equations if there are parentheses. So look for parentheses first thing and get rid of them by distributing what's smushed against them. Second thing you want to look for is if you have like terms on the left side of the equals or if you have like terms on the right side. If you have like terms on the left side, you combine them. And like terms mean an x with an x squared with an x squared, a y with a y, a number with a number. So this 5x and this -2x, those are like terms, so I can combine those two. So 5x minus 2x makes 3x. As long as they're on the same side of the equals, you just do what they say. 5 minus 2. I have other like terms over here too, though. This +8 and this +9. Those are just plain numbers called constants, and we can combine those. So +8 plus 9 makes a +17. And then I bring down the equals, and then I bring down the 38. Now we're looking at exactly what the last lesson was like. We're just down to a little two-step equation at this point. So remember, whatever's smushed with the variable or divided with it, you're saving that for last. You want to move what's next to it first. So to zero this out, to make it completely disappear, we're going to get rid of addition of 17 by subtracting 17. That way 17 minus 17 is 0. Shoop, it's gone. The 3x comes down. The equals comes down, and then 38 minus 17 makes 21. And then to get x by itself, I need to undo this smush, undo this multiplication with division. So divide by exactly what's in front of the variable. That way 3 divided by 3 is 1, but as long as it's a +1, you don't have to write it. And 21 divided by 3 makes 7. And that's our answer, and we're done. So from here down, this was the lesson before. What was new to us was distributing what was smushed with the parentheses and then combining like terms. Okay, not so bad. All right, so be on the lookout for parentheses in every problem first. If there's no parentheses, we go to the next step, which is looking for like terms on the left side of the equals or like terms on the right side. Okay, so looking at number 2, do you see parentheses? Yes, you do. So you're going to distribute whatever's smushed against them, and it's a +3. So we take +3 times 4x, which is a +12x, and we take +3 times a -5, which is a -15. I bring down the equals, and I bring down the -40. And then this -7x that was out in front, just drop it down. It didn't have anything happening to it, so it just comes on down. Okay, once parentheses are gone, you're looking for like terms on the left side of the equals to combine and like terms on the right side. So when I look on the left side, I do see some like terms. My negative 7x and my positive 12x are like terms because they both have an x. So I can combine those. So I just do what they say. Negative 7 plus 12. That makes a positive 5. So it's a 5x. Now my negative 15 doesn't have anybody to combine with this time, so just drop him down. And there were no like terms on the right side, so just drop down your negative 40. And now we're to a little two-step equation. So remember, whatever's smushed with the variable or divided by it, keep that by itself, save that for last, and zero out whatever's next to it. So to zero out subtraction of 15, I have to do the opposite and add 15. So I'm going to add 15 to both sides. So negative 15 plus 15 is 0. Shoop. Bring down the 5x. Bring down the equals. And then negative 40 plus 15 makes a negative 25. Remember, if you have a negative and a positive, subtract the numbers, take the sign of the bigger. And then to undo this smush, to undo this multiplication, I divide. And I divide by whatever's in front of the variable. So 5 divided by 5 is 1. So it's 1x. I just don't have to write the 1. And negative 25 divided by 5 makes negative 5. And that's our answer. What do you think? It's not so bad, is it? Okay, let's look at number 3. Looking at number 3, first thing off, do you see parentheses? Yes, you do. So let's distribute. So let's see what's smushed in front of them. And it's a negative 2. So we need to take negative 2 times negative 5x, and we need to take negative 2 times positive 12. So negative 2 times negative 5x is a positive 10x. Negative 2 times positive 12 makes a negative 24. Bring down your equals. Bring down your negative 64. And then this negative 2x that was out in front, just drop him down. Okay, now you're on the lookout for like terms. So first look on the left side of the equals, and then look on the right side. So on the left side, do you see any like terms? Yep, these two x's are like terms, so I can combine them. So I just do exactly what they say. Negative 2 plus 10, and that makes a positive 8x. Bring down the minus 24, bring down that equals, bring down that negative 64. And now we have a little two-step equation going on. So I'm going to save what's smushed with the variable for last, and I'm going to zero out what's next to it. So to zero out subtraction of 24, I have to do the opposite and add 24. That way, negative 24 plus 24 is 0. Shoop, drop down your 8x, drop down your equals, and then negative 64 plus 24 makes a negative 40. And of course, you can always use a calculator to calculate that. And then to undo my multiplication, I divide. So I divide both sides by 8. This makes 1. So I have 1x or x, and negative 40 divided by 8 makes negative 5. And that's my answer. Okay. Now, let's look at another one. Now, this one is a little bit different. And I know it's a little bit different just by looking right away because I see an n on the left and an n on the right of the equals. So we're going to have something going on that's a little different than the first 3 problems. But step 1 is the same. If you see parentheses, distribute whatever is smushed against the parentheses. So in this first problem, my 7 is smushed against these parentheses. So 7 times n and 7 times negative 1. So 7 times n is 7n. 7 times negative 1 is negative 7. Bring down your equals. And then I have parentheses on the right side, so I need to distribute what's smushed against them too. So negative 2 times 3 and negative 2 times n. So negative 2 times 3 is negative 6, and negative 2 times n is negative 2n. Okay, step 2. You're looking for like terms on the left side of the equals, and you're looking for like terms on the right side of the equals. Do you see any like terms on the left side? Nope, that has an N and that doesn't. They're not alike. Do you see any like terms on the right side of the equals? Nope, that has an N and that doesn't. They're not alike. Okay, so I can't combine anything like I did in problems 1, 2, and 3. Okay, you only get to combine things if they're on the same side of the equals. So no combining. But my problem is I can't have a variable on the left side of the equals and a variable on the right side. So I need to move one of them over from one side to the other. And I always like to move the smaller one. So a positive 7n is bigger than a negative 2n, so I'm going to move the negative 2n. I want it to completely disappear. And the way things completely disappear, the entire term completely disappear, is to zero it out. So anytime I want to zero something, I have to either add it or subtract it. So to get rid of subtraction of 2n, I have to do the opposite and add 2n. And remember, if you do it to one side of the equals, you have to do it to the other side. So now, negative 2n plus 2n is 0, and it's gone. Shoop! All I'm left with is negative 6. Bring down that equals. Bring down that negative 7. And then I can combine these because they're both n's. So 7n plus 2n makes 9n. And now we're left with a little two-step equation. Okay, so whatever's smushed with the variable, once I only have one variable, that's the key here. Up here I had two of the variables going on, and I can't have that. So once there's only one variable, whatever's smushed with it, save that for last, and zero out whatever's next to it. So to zero out subtraction of 7, I do the opposite and add 7. So negative 7 plus 7 is 0. Shoop, it's gone. Bring down that 9n. Bring down that equals. And then negative 6 plus 7 makes a positive 1. And then to undo multiplication, we divide. So I'm going to divide both sides by 9. This makes 1, so I just have 1n or n. And then 1 divided by 9, 1/9. I can't divide it, I can't reduce it, so I just leave it 1/9. And that's my answer. You may not think it's pretty, but I think he's pretty. I'll give you a little tiny smiley face. Smiley face. All right, let's look at number 5. All right, once again, do you look for parentheses first? Yes, you do. Do you see any? Yes, you do. Okay, so on the left side, let's see what's smushed against them. It's a negative 7. So we take negative 7 times 2x and negative 7 times negative 13. Okay, so negative 7 times 2x makes a negative 14x. And then I need to take negative 7 times negative 13. And I'm going to use my calculator real quick because I just don't want to make any mistakes. So negative 7 times negative 13, and I get a positive 91. Okay, this 3x that was in the very front, just drop him down. Okay, are there parentheses on the right side? Yep. So I need to distribute the 3. So 3 times negative 2x is negative 6x, and 3 times 9 is 27. All right, the next step is to look for like terms on the left side of the equals, and then look for like terms on the right side. So looking on the left side, do you see any like terms? Yeah, these x's. 3x minus 14x. So 3x minus 14x makes a negative 11x. The 91 doesn't have anybody to combine with, so I just recopy it, bring down that equals. Now let's look on the right side. Are there any like terms on the right side? Nope. This has an x, this doesn't. So you can't combine them, so just drop it. Okay, so the combining is over. So now when you see a variable on the left side and a variable on the right side, you can't have that. You can only have one variable. So I need to move one of them over to the other side. Now, quite honestly, it doesn't matter which one I move. I can move this one over, or I can move this one over. I always move the smaller one so I can deal with positives. And a negative 11 is smaller than a negative 6. So I'm going to move him. So to move him, you have to zero him out. That's the only way to make him disappear, is to zero him out. So to make a negative 11 turn into 0, I have to add 11. So I'm adding 11x to both sides. Remember, if you do it to the left side, you do it to the right side. So negative 11x plus 11x is 0. Shoop. Bring down that 91. Bring down that equals. Negative 6x plus 11x makes 5x. And then bring down that 27. Now there's only one variable, right? So now we're down to just a little two-step equation at this point. So once you only have one variable, save whatever's smushed with it or divided by it for last, and get rid of whatever's next to it by zeroing it out. So to get rid of addition of 27, we do the opposite and subtract. The 5x will come down, the equals will come down, and then I need to take 91 minus 27. And 91 minus 27 makes 64. Okay, so now to get x by itself, I need to get rid of the 5. So to undo multiplication, I divide. So I'm going to divide both sides by 5. This makes 1, so all I have left is x. And then 64 divided by 5. I do not believe that that divides nicely, but let's say you don't know. So I'm going to put 64 divided by 5 in my calculator. Oops, 5. And I get this decimal. I can turn it into a fraction if I go math, enter, enter. So math, enter, enter will reduce my fraction for me. And you'll see it's still 64 over 5, which means it doesn't reduce. So I'm just going to leave it 64 over 5. I'm perfectly fine with fractions being answers, but if you can reduce them, reduce them. If you can divide them out, divide them out. But if you can't, then just leave it. Okay, let's look at the next one. So first step, look for parentheses. Do you see any? Yes. All right, so let's distribute. So I'm going to distribute what's smushed against them. So 2 times negative 5 makes negative 10. And 2 times negative 3a makes negative 6a. Bring down your equals. Is there anybody to distribute on the right? Any parentheses? Nope. So just recopy it. All right, after parentheses are taken care of, you're on the lookout for like terms. So look for like terms on the left side, and then look for like terms on the right side of the equals. Do you see any like terms on the left? Nope. Do you see any like terms on the right? Nope. All right, next look for whether you only have one variable or not. And you don't. You have a variable on the left and a variable on the right. Can't have that. So I need to move this over here, or I need to move this over here. And like I said, I always move the smaller one. So to make this go away, I have to make it turn into 0. So to get rid of subtraction of 6a, I have to do the opposite and add 6a. And if you do it to one side of the equals, you do it to the other. So this way, negative 6a plus 6a is 0. Shoop. Bring down that negative 10. Bring down that equals. And then 7a plus 6a makes 13a. And then I'm going to bring down this plus 3. How many variables do you see now? Just one. Yay! As long as we only have one variable, we're down to our little two-step equation here. So whatever's smushed with the variable or divided by it, save it for last, and get rid of who's next to him on the same side of the equals with him by zeroing it out. So to zero out addition of 3, I have to do the opposite and subtract. So 3 minus 3 is 0. Shoop. Drop down that 13a. Drop down that equals. And then negative 10 minus 3 makes negative 13. 2 negatives add to make a negative. And if I needed to use my calculator to type that in, I would type in negative 10. So here's my little negative. So negative 10, so you can see it. And then minus 3. So now I would hit the minus button. So minus the 3. and you can see it's negative 13. All right, to get a by itself, I need to get rid of the 13. So to undo multiplication, I divide. So I'm dividing both sides by 13. So 13 divided by 13 is 1. So all I have left is a. And negative 13 divided by positive 13 makes negative 1. And that's my answer. Okay, I think I'm going to actually just skip number 7. It's just like all the others, so I'm going to just skip it for time purposes. But I'm going to look at 6 and 7 because they are slightly different. Okay, looking at number 6. Do you see parentheses? Yep. All right, so here we go. We're going to distribute. So 3 times 2x makes 6x. 3 times negative 4 makes negative 12. There's no like terms on the right side. There's no parentheses on the right side, so just drop that down. Okay, now be on the lookout for like terms. First look on the left side of the equals, and then look on the right side. Any like terms on the left? Nope. Any like terms on the right? Nope. Okay, now how many x's do you see? 2 of them, one on the left, one on the right. We can't have that. We need to move one of them over to the other side. So this time it doesn't matter which one I move because they're the same. So to move it, you're zeroing it. So to get rid of a positive 6x, I have to subtract it. So 6x minus 6x is 0. Shoop. Bring down your negative 12. Bring down your equals. 6x minus 6x is 0. Shoop. Bring down that 10. Now look. Uh-oh. Our variables disappeared. Okay. If your variables ever disappear, they zeroed out here and they zeroed out here, we either have a true statement that we're looking at or we have a false statement. So let me ask you, does negative 12 equal 10? No, this is a false statement. And if you get a false statement, that means there is no solution to this problem. And another way to show no solution is a 0 with a slash through it. And that's the answer to this problem. All right, none of the others up above did that. But this one, those x's zeroed out and these x's zeroed out, so you didn't have a variable to solve for. So if it's a false statement you're left with, it's no solution. Let's look at number 7. Do we have any parentheses to get rid of? Yep. So let's distribute. Negative 2 times 4x makes negative 8x. And negative 2 times negative 5 makes a positive 10. There's nothing to distribute over here, so just drop it. Now let's look on the left. Do you see any like terms to combine? Nope. Do you see any like terms on the right to combine? Nope. But I do see that there's an x on the left and an x on the right, and I can't have that, so I need to move one of them over. So to zero this out, I have to get rid of a negative by adding. So I'm going to add 8x to both sides. So negative 8x plus 8x is 0. Shoop. Bring down your 10. Bring down your equals. Negative 8x plus 8x is 0. Shoop. Bring down your 10. Now, the variables are gone again because those zeroed out and those zeroed out. So is this a true statement or false? Does 10 equal 10? This is a true statement. So this is all real numbers. And there is a symbol for all real numbers, and I want to show it to you. So I make 2 straight up and down lines like this, and then I make an R. So this looks like an A for all, and this looks like an R for real. So all real numbers. And that's the answer to this problem. So what this means is there is no number you could possibly put into this x and put into this x to make the left side equal the right side. Nothing. Nothing in the world that you could put in that x and put in that x so the left equaled the right. But I'm sorry. That's what this one means. That's what no solution means. I'm sorry. There's nothing you could put in this variable and put in this variable so the left side equaled the right side. That's what no solution means. Over here, I'm sorry, I misspoke earlier. All real numbers means no matter what you put into this variable, as long as you put it into this variable, the left side will always equal the right side. And you could kind of tell that from up here once you distributed. Did everybody see that the left side looks just like the right side? Well, since the left side looks just like the right side, that means that every answer would work. Everything that you plugged into X would make this true. That's why it's called all real numbers. Okay, and that's the end of this lesson. Smiley face.